So 0.9 repeating is equal to 1. 0.8 repeating should be equal to 0.9, right? So then 0.1 repeating should be equal to 0.2. And 0.3 repeating should be equal to 0.4. So 1/3 is actually 0.4. Which would mean that a whole is 1.2, right? 0.4 times 3 is 1.2. So many, it's like I keep saying, like 10 is adding tenths. It's really screwing everything up. And it comes because and you take our calculators are adding 0.0 repeating ending in 1. What that means is a set of zeros that end in 1. And if your calculator display on your phone or your calculator in general, they always have a limit of digits, right? So before you get to exponents. So our calculators are adding 0.0 repeating ending in 1. Because anything from 0.5 repeating, and they round up at the last digit. 0.5 ending in 6, right? And so on. All the way to 9. I swear, every time I make a video, I just burp. I don't know if I'm like just oddly camera shy. This is just a reaction. Anyway, I didn't think about this all morning. And so that's where that extra value comes from. That's why 0.9 repeating doesn't exist. However, 0.9 repeating plus 0.1 repeating should equal 1. I mean, it makes sense, right? You have a series of 1s, 2s, 3s, 4s, 5s, 6, 7, 8, 9. 1.0 repeating. Instead, because then you have 9, and then you get to 10. 0.1 repeating at the 10th interval is 1.1 repeating. However, to go from 0.9 repeating to 1 takes 0.0 repeating ending in 1, which is 0. So we're adding 0, and we're saying that 0.9 repeating is, in fact, 1 until you don't have an infinite set of 9s. If you have a series of 9s from here to infinity, minus infinity minus infinity, or whatever, where you just get this one little value less than infinity. That's our limit, right? Any more than that, and we're at infinity again. So it takes that many digits of repeating zeros ending in 1 to equal 1. So if 0.9 repeating takes 0 to equal 1, and I take 1 divided by 3 divided by 3, and that equals 0.1 repeating with an infinite set of zeros, adding that 1, it doesn't equal 0.2. That doesn't make any sense. That's irrational, right? That's illogical. You have this inconsistency. And and then it's just the same thing, right? But we've been so trained to round up at 0.5. But at 0.5, repeating, because it ends in a 6, and you add that 0.0 repeating, ending in 1, all of a sudden you have 0.5 repeating, ending in 7. Because 9 resets at 0. It's supposed to reset at 1. Because 0 is nothing. Infinitely nothing, right? 0.0 repeating ending in 1 is equal to 0. Until you take infinity, multiply it by 0. And then you have 1. Because they run in different directions, right? One with an infinite set of zeros. After, that's infinity. 0.0 repeating ending in 1 is equal to 0. That's infinity. And then if you multiply them, you're left with 1. It just boggles my mind how you can have 0.1 repeating and you can add them up, and you can have 0.1, 0.01, right? 0.11 takes 10.1s, it takes 100 0.01s, because those are tenths, hundredths, thousandths, and so on. Accumulation of that number to equal 1. So then at 0.1 it takes 10 to equal 1.0. But then at 9.0, with 10.1s, left with another 1, but it's 1, 0, 0. Just remember 10's not a number, because it's nothing. Since 0 is equal to 0.0 repeating ending in 1, as we know, because of 0.9 repeating, then 1.0 repeating ending in 1 is the same thing. And then you add 2 of those, and so on and so forth. Right? So then you have an infinite amount of numbers that equal to 1. Since infinity times infinity, well, depends on your decimal place, right? Infinity times point infinity is equal to 1. It's just silly. I don't know, what's the whole point of this? It's just fun to think about number theory for me. Trying to understand all these paradoxes of number theory, like I said. Because 0.1 repeating, and you go up to, it's only until 9 that it resets at 0 instead of 1. But if it reset at 1, what would you do? So if we had a 0.9 repeating, and we fixed our calculators to do so, and you add 0.1 repeating, at the very end, what are you looking at? Wouldn't it be 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9? So on and so forth, over and over again. Otherwise, if you add that 1, that 9 becomes a 0, 1 carries over. And now you're left with 11 there. You got 1 there. And another 1. Which then carries over and carries over and carries over, right? Infinitely. So you don't have a repeating number anymore. What you have is 1.1 repeating, ending in a 0 finally. It's quite a puzzle. You know, normal people, they just simplify everything. They rationalize paradoxes differently. They think, they just choose, they settle, they don't care. They're tired of thinking, they don't want to think. It seems. But, I mean, of course, numbers work, obviously. I mean, otherwise I couldn't drive my car, I couldn't. But you can always ask that same question. What is superior to that? What's a little bit better? Because we're always trying to do better things. Right? What worked in yesteryear doesn't work necessarily as well today. There's too many people. If we still made tractors like John Deere used to back in the day, we would run out of steel. Or, you know, there could be someplace else that you need just, if you over-engineered the tractor, you have more steel that you put elsewhere. And so it always goes into that, like 0.1 repeating, ending in 0. So 0.9 repeating plus 0.1 repeating should be 1.1 repeating, ending in 0, which is 1 digit less than infinity.